All right. Hello, everyone. Today I'm here to talk about the NTFS, otherwise known as the New Technology File System. It is the file system for Windows, and it's been currently supported today up until Windows 11. Hello, everyone. This is me. Hi. I hope everybody knows me. Head of research, yada, yada, yada. Incoming red team intern at SRA. Windows, weary, yes. And retired blue teamer. Okay, so what is NTFS? So NTFS is the New Technology File System developed by Microsoft in 1993. Originally, it was a replacement for the file allocation table, the FAT file system, and the high performance file system, HPFS. So back in the 1980s, Microsoft and IBM were working to develop a faster file system for these upcoming GUI-based operating systems. So up until about late 1980s, they were working on a file system called OS2. However, that functionality wasn't really enough for like the upcoming Windows NT operating systems. So Windows decided to say, bye-bye IBM. We're gonna create our own shit now. So that's how the NTFS kind of came to be. It supports significantly larger disks and higher volumes. So it's on so there's MBR, master boot record, and GPT partitionings. Disk size can be up to 8 petabytes, I believe. The 8 petabytes per disk. Highest file size is also 8 petabytes, so very, very large. FAT only supports up to FAT32, 32-bit files, so it's significantly less. So starting in Windows NT 3.1, which was back in like 1993, it is the default file system of the Windows NT family. So how does it work? So we're going to kind of go through each kind of detail of NTFS and how it's kind of structured. So files are stored as bitmaps opposed to what FAT file systems are stored as. So FAT stores files as linked lists, and bitmaps are a little different. I'm not quite sure how exactly, like what the details of a bitmap is, but that's how the NTFS stores their files. When a file is created using NTFS, a record about a file is created. In the master file table, which we'll get onto later, the record is used to locate a file's possible scattered clusters. NTFS looks for a storage space that will hold all the clusters of the file, but it isn't always able to find one space altogether. So in this case, clusters, NTFS uses this clustering system of kind of partitioning out logical space versus physical space. And we'll talk about more of those features in a little bit. But this is used for faster indexing, and it allows for a lot of the features. Let's get into it. So this is kind of the example of a FAT file versus an NTFS file. So a regular FAT file, it only has an attributes and the data contained. So attributes being like read, write, the permissioning stuff, data and the actual content of the file. NTFS has attributes, which we went over around week 2 with Red Team Windows and earlier last semester with Windows. So we'll get into that. Security controls as well, we went over last semester and this semester. So another thing that separates NTFS files from FAT files is it allows multiple data streams. So if you guys heard of alternate data streams, I think we talked about it a little bit earlier in the semester, where you're kind of, it's using this concept called forking. And so it doesn't show up as like a list as the file size, but it's actually like linked to it, kind of. If you think about like forking processes, it's a very similar idea. And there's another reason about why NTFS supports multiple data streams, which I'll get into later. So I think I'm skipping a slide. Oh, there we go. Yeah, that's That's why. Okay, so the features of NTFS, it's access control lists, file system encryption. So earlier file systems, it was doing DESX, which was a offshoot of the data encryption standard developed by IBM and NSA. Now currently it's using AES encryption. I believe it's CTR, quote me if I'm wrong. Transparent compression, so NTFS utilizes LZ77 compression. It's a form of lossless compression, which I won't get too much into, but sparsing files. So this is what I was talking about earlier with the clustering. Possible scattered clusters. So the NT kernel kind of maps each file with an allocated amount of space, and it's used to kind of save physical space. So, and there's a difference between physical space and the logical space. So there's like this allocated amount that the memory knows it has, but in actuality, physical space is taking up much less memory. And so sparsing files allows much more faster indexing for the file system. NTFS also supports file system journaling. So that's kind of, think about it as like Git, kind of. It's saving changes on the go, on the fly, using what's known as meta files and then alternate data streams. So interoperability is a big thing of NTFS. So Windows kind of saw their opportunity to kind of hold their space in this new, back then, the new golden age of tech and web, to kind of have these backwards compatibility as well as forward compatibility features. So NTFS has support for FreeBSD, Linux, macOS. There's actually even an open source fork of NTFS, which is used for Linux operating systems. Not every single one has read-write capabilities, though. So you might only have read features for certain Linux flavors. Okay. Sorry, I'm skipping around a little bit. Okay, so now we're going to get into the NTFS partition structure. So the partition has a boot sector, and that's going to hold the boot information. So that's going to be like about a 600 byte beginning of the partition where it's storing the information about the partition. So type, device, what kind of file system it is. Of course, it's going to have NTFS because this is NTFS, but there's also backwards compatibility that is available. It was very interesting because some of the records, some of the locations in the record weren't unused for some reason, and I'm not sure if that was for parity reasons. That might be a very interesting thing to look at. There's also this master file table that stores a record of all files, folders in the file system, as well as the meta files for each file. A series of meta files that help structure metadata more efficiently, and data streams and locking mechanisms, which I will not go into locking mechanisms for this presentation. So now we'll get into the master file table. All file directory and a metadata metafile data file name. That's a weird thing to say. Creation data, creation date, access permissions by the use of ACLs, and size are stored as metadata. So this was kind of developed because it was easy to add new features in the NT development. So like new server line features, and the articles I was reading was the Active Directory stuff that was added into kind of indexing with LDAP as well. It enables faster file search and locate named local files and folders, including MFT included in the master file table very quickly without requiring any other index. I know this might be kind of ironic because Windows is so big. but they have made significant improvements. I'm pretty sure everybody has noticed. Back in like 2010s, it was very slow, kind of indexing through Windows files, but now it's a lot more faster because they've made some significant features that were allowed through this master file table by adding, other additions. So right here we have an example. So this master file table is storing the meta files. So anything beginning with the $ is unusable. So you can't name like users cannot create like these files on their own accord. And yeah, so it's an example file record. We got our standard information file name, the data streams, additional attributes, and additional features. I'm not quite sure what those are, but yeah. And meta files, so these are defining files, backup critical file system. So a lot of these kind of additional files that kind of help the operating system keep track and that allow data recovery as well in case of a system crash, BSODs, blue screen of deaths, right? And very common in Windows, right? And it likes to freak out. So yeah, there's a lot of these meta files listed here. So we got examples like the MFT describes the MFT meta file, master file table. And there's also this duplicate backup, right? Another key feature of the NTFS. There's also this log file, which is another feature for file journaling system. So it records the changes that's been made to each file. And yeah, another thing that I read was that this volume file was very strange. This might require some further reading, but yeah. And then attributes, MFT attributes that associate numeric identifiers with names. And then also some boot records and bitmap entries. And so this is kind of the visualization we have right here. So the master file table right here, and then we got the MFT. It's kind of sideways, but we have the MFT meta file, the MFT mirror file, the copy. It also has the directory and then the file. And these are all associated with kind of bitmaps, and it's also linkless, it seems, or memory associations. I'm not sure. But yeah, that's it. And are there any questions?
What do you think the point of alternate data streams was?
So for alternate data streams, it originally was for interoperability, so the backwards compatibility. It was originally made because they wanted to support Macintosh files and applications. But then once they kind of burned that bridge and they started using it for other like identifier stuff. So for example, they would attach it to like a website sometimes. So like the incoming connection have an alternate data stream for that to signify it was malicious, it's stuff like that. It was also used for malicious purposes. Alternate data streams can be used to hide data. They don't appear in File Explorer as like the file size. It could be a different file size from the original one for the alternate data stream. So it could be used to hide executables and things like that. However, there's already a lot of detection for that. So the original purpose is kind of unknown. It's weird. It's Windows. I love it. I hate it. They do some wacky stuff. Any other questions? Okay. All right. These are the resources I used. O'Reilly has some good books. Also, this YouTube channel, if you guys heard of FlyTech video, very, very cool stuff. They do a lot of kind of wacky things with the Windows operating system and NTFS like file system stuff, like they were able to have folders with just spaces, which is kind of strange because NTFS files only support UTF-16 up to 255 characters, but they were able to just fill that with only spaces, which you can't do because it's excluded. I haven't watched the video, but go check it out if you are interested in more Windows stuff. Highly recommend. And yeah, that's it. Thank you so much. And this concludes the research portion of RIT6. So thank you. Have a nice day.